In the last class, we have discussed that what are the different aspects of meaning associated with any word we should be aware uh, while defining or while defining or looking for methods to represent a word into a d-dimensional vector representation. So in this class, our focus would be to discuss some of the initial methods which were used to obtain such vector representation. So overall, if you try to divide these different vector space model or vector representation models or word embedding, so it comes, known with all these different ways. So you can sort of broadly divide into the two or three big categories. The first one is about the long and sparse vector representation, and why I was sort of saying two, because the first two is very commonly used, and the third ones are in fact for example, the methods which are based on the Brown clusters are not so commonly used. Of course, then there are methods which um, I have called hybrid method because these methods are kind of a, if you look into the way the method the vector representation has been obtained, it is it uses some of the properties which the methods which generally obtains the long and sparse vector representation based on the co-occurrence matrices. So it uses some of those properties, and then it also look for a method which is so primarily, in case of the sort and dense vector representation, where these neural models are more popular, there you see that often it's a more on focus on the local context, and the globe is basically a combination of these two ideas. We will discuss in detail while towards the end of our discussion about the vector semantics. We will discuss in detail how the globe is a hybrid method. But in summary, we can say that there are two broad categories. One is the long and the sparse vector representation method, primarily based on these co-occurrence matrix-based methods. And the second is the sort and dense vector representations. So either they use some dimensionality reduction techniques such as singular value decomposition uh, from the first type of the methods to get the sort and dense vector representation, or they use something like the neural language based methods to obtain the neural models which try to obtain the sort and the dense vector representation based on local context. Um, So let's first focus on the co-occurrence matrix-based method, because it's kind of you can say that it's a building block of any kind of a models which is generally used to obtain a vector representation. And these matrices are often try to count how often words are co-occurring. Of course, there are different measures which has been defined over the over a time period, which sort of reflects different properties of these the co-occurrences. Again, some of those properties we are going to discuss in this class. So that's what I said, that we will look into some of the ways to construct such co-occurrence matrices. So one of the example is a term document matrix, primarily used to obtain document vector, and especially this was a very popular in early days of this information retrieval, or you can say that for search engines. So where the idea was that you um, represent all the words in your vocabulary in rows, and then all the documents in your collection is represented over columns. And in each increase in the cell is basically some form of a count of word D in a document D. So this, of course, the simple is that you just take the raw count, or you can take some frequency of word W in document D. So then, once you do that, so then you are obtaining, so that any column vector gives you a representation of a particular document over these vocabulary set. So that's, in simple way, the document vector. And so I have already said that this term document matrix was initially defined as vector representation for documents. And each document now is being represented in the b-dimensional vector space. So this b is the number of words in your vocabulary set. And the idea was to take the similar documents tend to use similar words. Uh, and these, such vectors are generally used for document clustering and several other information retrieval tasks. So this is just an example, as you can see that in the previous slide, uh, you can see that we have shown these four documents over some set of the words, and here just to indicate how these representations are, we have taken the two particular dimension or the two particular words in my vocabulary set, and then see that how these documents are being represented. And as you can see that as kind of it's expected, uh, the word battle is more likely to occur in the play of Shakespeare's like the Henry and the Julius Caesar. So this collection is basically the plays of written by Shakespeare. So and for the these play As You Like It and Twelfth Night, you see that these two are very similar because they are using these word pool quite frequently. uh, and of course these two plays, As You Like It and the Twelfth Night, uses this battle word very infrequently, and that is why it is sort of coming with a very low value here. You can see, and and if you want to now look into the document similarity, then you can see that As You Like It and Twelfth Night is very similar, and then Henry V and Julius Caesar is also very similar. Now, this term document matrix can also be used to represent word vectors, and just simply what you have to do is that you have to just take the row vector, because the words are being words are given in the rows. So, if you take any row vector, then that will give you a vector representation for word, although this is not a very common or standard way, but still we can consider this one. And you can also see that, what is our expectation that the words, if the two words we can look into it and then try to find out their similarity. So if these two words are very similar, then they tend to occur in a similar kind of a document. So their frequency would be more on similar kind of a documents compared to the other words. So here again you can see that the battle and the pool, if you compare, the battle is occurring very frequently in case of in the documents Julius Caesar and Henry V, compared to As You Like It and Twelfth Night. So, if you try to look into the similarity between the battle and the fool, this would be very less similar. But if you look into the similarity between fool and clown, it will be very, highly similar. So again, our distributional hypothesis is, this is again linked to the distributional hypothesis, and that the meaning of the word you can be inferred from the document it tends to occur in, and the similar words tend to occur in a similar kind of a document. But the very, as I said, that from the term document matrix, it is rarely that you are interested to use a word vector from that matrix. It is primarily used to obtain vector representation for the documents. Uh, the most common way to obtain a vector representation for words is from the term matrix, or what we call is term context matrix or word matrix. Uh, the term context matrix is a very commonly uh, way to you know call this such matrices. The reason is that you know in row you are representing the words for which you are interested to obtain its vector representation, and the columns are basically the context. And now this matrix can be converted in fact into a, you can say that the term document matrix is a special example of the term context matrix, where the context becomes the, let's say that, the document. But in generally, that's the way we use the context in a different way. So let's look into the way that some of the ways in which we often use the context. So of course, this matrix is of the V cross V matrix, because your columns in the context often it's again the the words which are being represented in the columns as a context. Now, what it means? So, in each cell, you record the number of times the row, or what we call is the target words. So target words, again, I want to emphasize here is that this row vector is actually giving you the real representation which you are going to use. So that is why it's called the target words co-occur with the column word or the context words. So now the context again can vary. So if the context is a document, then how many times the two words co-occur in the same document. So again, let me repeat what I meant. So in your columns, still you are going to write only the words. Okay, in the matrix there we have so your rows is, let's say that W1, uh, W2, and WV. Uh, and the columns is also W1 to WV. Now, when you look into mm, the word W1, or the row, the first row, then you see that how many times. So the W2 has occurred in the same document. Uh, and so I mean, of course, then so the both W1 and W2 has to be there in that particular document. So how many times the two words co-occur in the same document? So you have again collection of the documents and then you see that how many times in each of the documents these words co-occur, and then you just add them together, and then that's what your entry is. Uh, then another way to look into the context is that you, whether you are considering a single document or you are considering a collection or a document, what you are going to do is that you are going to look into a smaller windows around the target word. So if your target word is W1 in your in the row, and around that word you look into the n words in your corpus collection, and then see that how many times these column words are occurring uh, within this window of n word, either side of the that this target word. Uh, so so here you are looking into the local context, and within that local context you try to count the number of times these context words are appearing with uh, your target word, and that number goes into the matrix. So so you will, whenever let's say that you see your target word in your collection, you create a window of around n words, and then you see that what are the words which are occurring for each of the words there. You increase the count, and then you keep doing it for each of the windows for the distinct occurrence of this your target word, and then you sum based on that whatever you have obtained, that gives you your cell entries in the matrix. So as you can see, the first example when we talked about a document, so that looks into a more the global context. So it will not necessarily that the two words are occurring within a sentence or within n words. One word can occur in the beginning of a document, and another word can appear at the end of the document, but still it will count. But in the second way, you are more focused on the local context, and then you are going to see that when I mean, only if the context words appears within the n words of your target word in that particular context, in that particular window, then only you are going to consider its count has only then you will increase its count, otherwise not. Uh, so these are some examples, but then there are lot many variants of it if you look into the literature. So for example, there are methods when they consider. So for example, here I have said that whether any context word appears in the right side or the left side of your target word, you just don't uh, differentiate whether it is appearing on the left side or the right side. But then there are methods which actually takes that also into account, that whether if word appears on the left side, then it treats or it has a count, separate count for that, and if it appears on the right side, then it has a separate count, and then they interpret in different way. So again, these are only two examples I have given here for the term context matrix or term matrix, but then there are a lot many variants exist in literature. Here is an example that these are my the target words, and then you have considered your collection of a document. You look into the particular window size, and of course you can see that how the tokenization has been done here. That sugar is one word, a sliced lemon is a single token, a tablespoonful of is a single token, and then so on, and so on. So this is what the way it is taken. And uh, then it actually now counts the number of the different context word. So in case of the apricot as a target word, now you see that the pinch has appeared once. So there is a pinch. So if you assume that this is the your total collection of the document, then this has occurred just one time here. So you have the one here, and similarly, for other cases. Now, uh, uh, you know, uh, and again, if you want to look into the similarity among these words, you will see that the apricot and the pineapple have a similar kind of a context to words. Compared to, let's say, that a digital information as a pair, they are having a very similar kind of representation or a similar kind of a context to words are there, and they are more similar than digital information are more similar than any other words here, the apricot or pineapple. So now the question is for us that you know what kind of a window size we are going to consider, or what kind of a context we are going to consider. So it has been sort of observed that if you are considering a shorter window, then you are going to obtain a more syntactic representation, and you know they would be uh, having, if you try to compare, once you, let's say that you have considered a shorter window, and then you have obtained a representation for all the words in your vocabulary, and then if you want to look into the similar words, so then what often you will find is the words which are, you know uh, uh, leading to kind of a similar kind of a part of speech. So this is more like a more syntactic representation it obtains, so that because if you are considering only smaller context, perhaps it is not able to capture much of the meaning associated, or hidden in the sentence, and it's only able to capture some of the grammatical properties. So it's so you can say that it can reflect maybe the similar part of speech, the words of the similar part of speech, and so on. But if you consider a longer window, then because the context is bigger, then you are more tend to obtain a representation which is uh, you know uh, often going to be when topically related, or they are kind of representing a similar uh, semantic domain, or semantic domain in fact. So again, in the purview of, let's say, what we have discussed earlier, so you can say that the smaller window will lead to capture the some kind of a relationship which is more tailored towards something like called the semantic frame. If you remember what we have discussed regarding the semantic frame. And if you look into the longer window, then maybe you are able to obtain, the words which are able similar in the sense of the semantic domain. So that's what these the empirical observations tend to sort of show this kind of a behavior based on the mm, I mean, based on some of the analysis, that's what people have observed. And you may want to, while when you look for some methods, maybe you can also try to see that how, with the shorter window, what kind of a similar words you are obtaining, and if you consider a longer context or window size, and then what kind of similar words you are obtaining. Uh, Related to this discussion is when you talk about a co-occurrence, then we are uh, primarily looking two kinds of association. So first one is syntagmatic association, what we call is the first order association. So these words tend to occur too nearby to each other. So, for example, when you talk about drink, then often maybe the water is the first order associate, because uh, you don't say you want to eat water, you say that you want to drink water. So, of course, again, it depends on the language. So, if you are Bengali, then you will not say that. So, again, I mean, this is, just to sort of highlight this point that uh, this drink is a first order associate of water, and this is kind of a first order association, and they occur nearby each other. So if you consider perhaps the shorter window, this is the kind of a relation it might be able to your model is able to pick, the term context matrix will able to pick. Uh, when you talk about the second order association or the paradigmatic association, then what we are going to see that we are going to obtain a more similar word. So now if you are considering the drink, then you will obtain a sip and swallow. So these are the kind of the second order association, and with the longer context, perhaps we would be able to fetch this kind of association. Now, of course, the question is how to deal with these rock. I mean, whether just considering the raw count is good, or is it a bad measure. So the raw count may not be very informative, because as you have also seen in your earlier, the analysis, and as a part of your first assignment, there are many words which are very very frequent, but then they are there just to fill the the grammatical they to play the role of the grammatical, they are playing the grammatical role, instead of, let's say, that giving wider meaning, or having the more context. They don't provide more contextual information. So they may not have a very high discriminative power. So the choice of the raw word may not be good, and uh, then we have to perhaps look for some alternative. Uh, so the positive point-wise feature information is one method. Maybe you can read it from the Juravsky book, where he has discussed. Uh, So I will suggest that you go through it. So it will be a part of the course syllabus, but I am not discussing in a lecture. I will encourage all of you to read that particular section from the Zuravsky book. And then we have this term frequency, inverse document frequency measure. So that I will sort of briefly describe. Let's discuss this term frequency TF IDF. TF stands for term frequency, and IDF is inverse document frequency. So it's basically a product of two factors. The first one is the term frequency. It counts the frequency of a particular term in a document, and inverse document frequency is basically tries to penalize the words which are occurring in all of the documents. So if it occurs in all of the documents, then you should give a low weightage to such words. And if the words are occurring in a very few documents, then those words are likely to have more discriminative powers, you want to give them high weights. So accordingly, with that notion, this IDF is being defined, and it's the IDF for a particular word is defined as the inverse of the document frequency. And document frequency means of a particular word is that the number of the documents in the collection in which this word has appeared. So it does not count the total number of times uh, the word I has been appeared in the collection. Instead, it just sort of says that it's kind of in a binary that it goes through in each of the document and say that whether it has been seen in that particular document or not, and then just count that the number of such documents in which this particular word I has appeared. And then it sort of takes the inverse of it. So if there are total number of n documents are there, so then it takes n divided by the document frequency of the word I. And in both of the definition, often it's basically the log is used to sort of squash those the numbers. So for example, the term frequency, if some words are appearing too many times, 100 times in a particular collection, and if some words are appearing 20 times, it does not really sort of says that their relative importance or so. So they just wanted to, with the log, we just want to squash those numbers. And in the TF, we basically try to take care of the situation where you have the document, I mean, you have this count when it becomes zero. To take care of that, you just take the special definition as that is given on this particular slide. So the TF-IDF value for word T in a document D is given as a product of these two terms. Uh, and Yeah, so that's the way we define the TF-IDF value for a word in document D. And Uh, so, of course, if it is a term document matrix, then you can define this TF-IDF. But if it is a term context matrix, so often what we do is that we just take the co-occurrence frequency and weight it by the TF-IDF value of the context word. So that is the way the term context matrix uses the TF-IDF. Now, so if you have, let's say that you have defined this term context matrix the based on this TF-IDF idea. Now the question is, of course, you can, if you want to look for the similar words, you can look into the row vectors and then try to find out what similar words are there. You can also, and in fact, in the information retrieval domain, again, as I said, that it is a very, very common practice to use such kind of a representation. So if you want to look for a similar documents, what we do is that we try to find out all the words in that particular document. And for each word, now you have its vector representation. You just take the centroid of it, and that is sort of represents a document vector. And similarly, for any other document, you can do that, and then you can calculate the similarity. So TF-IDF is one simple example, and in fact, it's often the kind of a baseline people use, uh, you know, over any other method. So this is a kind of a baseline method you should always use when you're considering a different word vector based methods or word embedding methods when you are looking for. So that's it. So this is what is the one example of long and sparse representation. And again, the TF-IDF based representation or the raw frequency based representation, as you can understand and see, that it is the long vector because in case of the term context matrix, it's a V cross V matrix. So it's a long vector representation. Open the vocabulary size goes into tens to hundreds of thousand, and mm, many of the the word. I mean, if you look into the particular row, you will see that the many entries are zero because not all words in your vocabulary is going to appear in the context of a particular target word. So, whether you are considering TF-IDF based method or whether you are considering a raw frequency based methods, it's going to be a very sparse. So, in the next lecture, we will look into the method which is how to obtain a sort and dense representation, and we will look into the two types of the method. One is that we will see that how SVT based dimensionality reduction technique can be used to obtain sort and dense representation, and in the second we will discuss the globe vector representation.